Hi scientists, this video is for module number 4, and in this module we are going to apply math to science and calculate the amount of mechanical energy that an object has in different situations. As always, we're going to start off with a warm-up, so go to my Canvas page, click on current lesson, where make sure you're in module 4, and pause this video and do warm-up 4. Once you're finished with warm-ups, I want to give you a quick reminder before we get started with the rest of this, and that is about work that is already due. So the big thing is from Module 2, the Energy Skate Park simulation. So this was the Energy Skate Park simulation. We played around with the skater, but there's a Google document here with a lot of questions, and you're answering all the questions in blue or you're highlighting some answers. Make sure that you have this turned in. The best way to do it, by far, is to click the submit button on this Canvas page, but some people have been reporting issues with that. Let's go to the student view here. So when you, let's see if I can authorize this. I'm not sure if my student view will work. So if you're running into an issue like this and you are not seeing a submit button, I know many people have been able to do it, so this shouldn't apply to everybody, but your option would be to make sure that your Energy Skate Park document is in your science folder and it's shared with me. Because at the end of the week, if I don't have it in Canvas, I will search it in my Google Drive, and if you don't have it in the right place, then I won't be able to find it. So make sure that you have that turned in as soon as possible so that you don't get a 0 for that assignment in the gradebook. All right, now on with the show. So today in our module number 4, we are going to learn how to apply math to the idea of kinetic and potential energy. Now, by now, you should have the notes already. I realize now that I forgot to put the link here, so I'll fix that. However, if you haven't done module 1 or 2 or even 3, you should stop this video and go do those modules before continuing. This module here today, it is the last section of our Notes 1, Energy Basics. So make sure you get these out. Notes 1, Energy Basics. They should be in your I've Got the Power folder, Unit 4. We're doing the bottom section, Measuring Energy. All right, so here we go. Applying math to science. Math has many applications in science. Today we're going to use math to calculate the amount of potential or kinetic energy that an object has. So, in your notes, energy in any form can be measured in units called joules. Write down that word in blue, capital Joules. And we shorten that with a capital J because it's a name and it's named after this guy over here in the corner. So today we're going to learn how to calculate 2 types of energy, but no matter what type of energy we're talking about, if we're giving it a number, let's say I have 30 joules of thermal energy. Okay, so that's how our units work. We put it after the number. That is what we're counting in if we're talking about energy. That is the unit. So we're going to start with the easy one, which is the potential energy formula. For gravitational potential energy, the higher an object is, the more energy it is storing because it has more potential to fall. Gravity is also important because it is the force that moves the object. The mass of the object is also important because the heavier an object is, the more energy it carries with it. Consider dropping a super heavy object like a brick and a lighter object like, I don't know, a ball of paper. Well, one of those things is going to smash into the ground a lot harder and faster than the other, and that is the brick. So objects with more mass, they also have more energy. Therefore, the formula we can use is potential energy equals mass times gravity times height. So the M is for mass, the G is for gravity, the H is for height. So in your notes, you can write on the PE equals line just M, G, H. I like to space them out so it doesn't look like a word. And in the what do they mean line, so M equals mass, G equals gravity, H equals height. All right, now here is the extra piece of information that you're going to need to remember. G is the force of gravity, which is different on every planet, but on Earth, it is 9.8 meters per second squared. What that means is that all objects are affected by gravity the exact same way on Earth. This is different for different planets or on the moon, but we're going to only be worried about things on Earth, so the number that we're always going to use for gravity is 9.8. Remember that. Let's try let's try a word problem, an example problem. An apple is hanging from a tree branch 20 meters high. It has a mass of 0.23 kilograms. How much potential energy does it have? So if you were in class, we would circle the mass in blue and the height in red. Can you circle that in your mind? So the correct answer is the mass, using some context clues, has a mass of 0.23 kilograms. You should circle 0.23. Oops, I'm sorry. The height is 20 meters high. So 20 is what we're going to use for H. What is the force of gravity on Earth? Do you remember the number I gave you 2 slides ago for the force of gravity on Earth? Remember, it's 9.8. So we're going to do this problem real quick. An apple, so we know that, let me get my annotation tool going. We know that the mass is 0.23. We know that the height is 20 meters. Now we're going to put them into the formula. So formula is PE equals mgh. So PE, excuse my awful handwriting, equals M. M is 0.23. Don't forget your decimals. Put them in the right place. Now G is always 9.8. So here we go, 9.8. And H, height is 20. Now, I allow use of calculators for science. I would rather you get the answer right than make a silly math mistake. So 0.23 times 9.8 times 20 equals 45.08. So 45.08. Now you gotta put a unit. A number doesn't count in science unless we have a unit. And the unit I gave you at the beginning of this lesson is J for joules. Alrighty, great. Clear this. Let's go on to the next slide. Now let's try a little comparison problem. Let's look at 2 apples. One is 14 meters high and has a mass of 0.2 kilograms. The other is 20 meters high and also has a mass of 0.2 kilograms. Which one has more potential energy? Explain how you got your answer. Pause the video and think about it. All right, so one possible answer. The apple that is higher up has more potential energy because it has more potential to fall farther, and PE depends on gravity. Since they have the same mass, the mass does not matter. They are identical masses, 0.2 kilograms, so the mass doesn't make a difference in this problem. I'm going to stop this video here and continue in another one so I don't run out of time.